Now, first of all, I'd like to welcome everyone who are logging onto our webinar platform, okay, to participate in this interdisciplinary webinar. I'd like to say a few words about the Center for Water Technology and Policy. Yeah, for those who are joining this our activity, participate or attending, okay, this webinar for the first time. I'd like to tell you that the Center for Water Technology and Policy was established at the University of Hong Kong, okay, 3 years ago. It is an interfaculty collaboration between the Faculty of Engineering and the Faculty of Social Sciences. And my name is Frederick Li, and I'm the Executive Director of this center. Yeah. Now, we focus on water policy matters in Hong Kong and also at the global scale. Currently, we are focusing on water policy concerns here in this city and in a larger region. Yeah. Now, water policy matters, to be sure, are multidimensional. Okay. So it's our first attempt to bring in the engineers. Okay, and I mean colleagues from the Faculty of Engineering and our colleagues in the Faculty of Social Sciences who are interested in or have the expertise in policy analysis. Okay, so at the moment, the kinds of topics they're working on, okay, are focusing on what we refer to as the policy technology interface issues. Okay, matters that concern both the policy analysts and the engineers. Okay, and so this is what this is the reason why, okay, we are focusing on this topic for the day, water reuse. Okay, and for today's webinar, we are very happy to have two speakers, international speakers, one from the United States and one from Australia. And the webinar's title, okay, is Water Reuse in the United States and Australia, Obstacles and Solutions. Okay, so looking at this question of water reuse. Now, let me introduce the two speakers. Okay, the first speaker is Professor Daigger. Professor Daigger is a professor at the University of Michigan with the Department of Civil and Environmental Engineering. Okay, and the second speaker is Professor Leslie. Professor Leslie. Yeah. Mm-hmm. And Professor Leslie is a director of the Global Water Institute at the University of New South Wales. Okay, so I'd like to thank both speakers, okay, for joining us with long distance, remote. Okay, and we are now seated, okay, in the social science chamber. Okay, we have this banner right behind me, above me, okay, with the logo of the center. Okay, and so next to me, okay, sitting to my right hand side is Mr. Fung, and Mr. Fung is a chief engineer with the Drainage Services Department with the government of the Hong Kong Special Administrative Region. And next to Mr. Fung is Mr. Yip. Mr. Yip is the chief engineer with the Water Supplies Department of the Hong Kong government, of the government of the Hong Kong Special Administrative Region. Yeah. And then joining us, okay, remotely is Professor Li, Professor XY Li, with the Department of Civil Engineering at Hong Kong U. Okay, so Mr. Fung, Mr. Yip, and Professor Li will provide a rejoinder, okay, each, okay, after Professor Daigger and Professor Leslie deliver their talks. Okay, so I would first like to invite Professor Daigger to give a 20-minute presentation, okay, on the history and prospects for water use in the United States. Professor Daigger, please.
So thank you very much for allowing me to participate in this webinar on this, of course, this very interesting and important topic. So what you have asked me to do is to address two questions which are listed here. What are the obstacles to water reuse in the United States, and how were they identified, and how were these obstacles addressed, and to what extent were they addressed? And to do that, I'm going to make these following points and then come to the answer to those two questions. So first, describe the many forms of reuse that are available and used. It's very interesting. In your Q&A, you actually were going through some of this material. So those that were dialed in early, actually, this is a bit of replication of the material you've already had. But as you can see, there's quite a wide range of uses of reclaimed water that are available. And let me kind of bound these into some categories. So the first category is landscape irrigation, agricultural irrigation, and non-potable urban uses. And a point I'll make later is that technology is really widely available for any form of reuse. And I'll mention that as we go through here, because what you're going to see is a progression of technologies with these various types of reuse. So here it's just the removal of biodegradable organics and disinfection. Disinfection is the key thing that makes the water here useful for these uses. Industrial use is certainly, there's a wide range, but very often, in addition to the above treatment, is the removal of dissolved solids for many of the industrial uses. And again, the technology for that is well developed. Impoundments, environmental uses, this is actually producing water to enhance the environment. And so disinfection is important, but also nutrient control, because many times we're exposing the water to sunlight and algae can grow. And then finally, potable water reuse, either for groundwater recharge or to augment the potable water supply, with many also looking at direct potable reuse. So here, disinfection plus the control of trace constituents from a drinking water perspective. Water reuse is a long-term and growing practice in the United States. And I'll illustrate that here. I'm looking specifically at potable water, the reuse. The history goes back much further in terms of other forms of reuse, but it might be surprising that potable reuse was practiced at a large scale since 1962. There's been a continuous increase in that. This table goes through 2013. It's just as you can see, the table was published in 2014. And again, a variety of technologies, depending on setting, whether it's a coastal or an inland application. And again, just to illustrate the exponential use, this is again data up through 2015, and you can see the exponential curve here. Water reuse is common even when not recognized. And again, you had a slide that talked about de facto water reuse. This is illustrated on the left-hand side, where the Trinity River draining from the Dallas, Texas area is a major water supply for the city of Houston, two major metropolitan areas. But the treated effluent from the Dallas Metroplex is conveyed down and used in Houston. And when this has been looked at, there are tens of millions of people that their water supply is a fraction of treated effluent. So this is much more common than we think about. Reuse is becoming recognized as an essential component of the water supply portfolio in many locations. The portfolio approach to drought-proofing water supplies is becoming well accepted, and it's an essential component because of its reliability. It has superior economics compared to some other options. Desalination can be an example of that. And more complete wastewater treatment is becoming available, such as nutrient removal, which further enables reuse of different types. Relevant management monitoring procedures are well proven. Source control and quality control at the treatment level, and the methodologies for outreach to gain public support are becoming more well developed. and can be more successfully applied. This is a topic I'll come back to at the end of this discussion. Non-potable reuse is widely accepted and practiced in the U.S. This is a figure from a U.S. EPA publication, and you can see the highlighted areas, which are examples that were analyzed in this, but you can see the large number of additional dots here that give you a sense of the number of reuse applications in the United States. And of course, they're in the more water short areas, California, the southern part of the U.S. Through the Texas, Florida, up the East Coast, and even surprisingly in the Pacific Northwest. So areas where water is somewhat shorter than in other locations, but quite a wide practice in the U.S. Potable reuse is practiced and is becoming more widely accepted. Again, another figure from a more recent EPA publication showing both operating potable reuse installations. You see those in the darker color, but the lighter color showing the increasing number of planned projects that are in various stages of implementation. And again, this represents an exponential increase in the number of applications. And again, you see this in particularly in water short areas, California, Arizona, Texas, Florida, up the East Coast. But again, instances in the Pacific Northwest of potable reuse. These would be indirect potable reuse. California is developing standards for direct potable reuse, and there are examples in Texas and New Mexico of direct potable reuse that are functioning. But the technology is no longer a constraint to water reuse. I really made that point in the first point associated with the many forms of reuse, but it certainly is the case, and we can have some further discussion on that if you would like. The critical point here really is acceptance of water reuse, and it depends on a variety of non-technical factors. One factor that we've found to be quite important are the choice of appropriate words. Words have meaning to people, and this is some research from the conducted in the early 2010 area. Research in which people were surveyed in terms of their response to different words, and looking at whether providing information has been useful in terms of helping people to gain acceptance of potable reuse in this instance. But you can see the words along the bottom, and I know you're reading them faster than I would speak them here, but you go from something like drinking water, which everybody can understand, to technical terms like recycled water and reclaimed wastewater and so forth. Now we're asking people to not only understand the quality, but to understand the technology. So what we find is if we just stick to what the quality of the water is it of an acceptable quality in terms of drinking and so forth? Do people accept that? It has to be true, but if it is, people will accept that. And discussions on reuse, they oftentimes, as you see, start when someone is looking to introduce reuse. What the research shows is that this is presenting information about water and water supply options and the urban water cycle. That needs to happen well before the idea of reuse is introduced. people need to understand in order to accept. So here's then what I consider to be really a seminal publication and represents a consensus of the factors that have led to successful implementation of water reuse, particularly potable water reuse in the United States. I want to go take a few minutes here and go over the recommendations. So the first is to assess the utility's reputation among customers and decision makers before investing in planning for reuse. The implementing organization must be credible with the customers and decision makers. It is a founding and critical requirement for a successful program. Create and execute a comprehensive strategic communication, outreach, and involvement strategy to build trust and credibility. So these two words come back again. Interact with people, help them to understand what we're talking about. Use an external expert body to advise on the design and implementation and support evaluation of projects. And this is, I'm serving on one of these two of these bodies actually at the current time. Again, about providing that credibility by demonstrating that a credible outside body is reviewing. Assess the community needs, driving consideration of a project, and articulate how a project meets those needs and how different stakeholders may be impacted. So there has to be a reason, and people need to understand and in fact participate in defining the reason for the reuse project. Take an integrated water management approach. So consider reuse in the context of the other options. So understand the motivating drivers, prepare to navigate the applicable governance structures that will influence development of the project. Develop a comprehensive financing plan, considers community interests in long run. This is important in that not only the financing, but one must understand that that any new water supply project is going to be more expensive than the average cost of water that's being paid. The reason is the average cost of water is a composite of both the less expensive and the more expensive options that are currently being used. So the next increment of water is going to be more expensive than the most expensive source you're already using. Very important to understand that from a funding and a pricing perspective. Work actively with state primacy agencies to establish a workable regulatory approach. I think Greg will speak to that in his presentation. Some of the experiences in Australia really are duplicated and replicated in the US. Introduce potable reuse as a potential water supply option early in the water planning process, and foster collaboration and integration among water and wastewater utilities through watershed-based integrated resource management processes. Put reuse on the table right from the beginning, along with other water supply options, by a credible organization that also does their due diligence with all the potential partners, including the public health and so forth, and communicate with people, put it on the table and talk with people about whether it's the right piece. And if it is, ultimately people will support it. So these are the key points then that allow me to answer the questions that you've asked. So the questions are, what were the obstacles of water reuse in the United States and how were they identified? Well, the obstacles were the institutional capacity to successfully implement reuse systems. the evidence is very clear that utilities and the various institutions where they had the capacity that successful reuse programs were implemented. That was lacking. The implementation was almost universally unsuccessful, and public perception of pristine water supplies. You look at the amount of de facto water reuse, people are already drinking and using recycled water. It's just present in their water supply. Very, very, very common. People have oftentimes the perception that their water supply is absolutely pristine. How were these obstacles addressed, and to what extent were they addressed? So water reuse is undertaken by competent utilities that were also competent actors within their communities. So competent in terms of their ability to construct and operate, but also viewed as competent within their communities. That addresses the first barrier. And then effective communication with the public using proper language over an extended period of time. These have been the key factors that have led to, as you've seen, relatively widespread adoption and implementation of water reuse, both non-potable and potable, where it applies and where it is most logically applied. Again, in the context of a water supply portfolio to provide a robust and reliable water supply. I've provided with this some key references, and it's been particularly over the last decade, a lot of the knowledge and experience, both some of these US focused, but some of these also international, but the knowledge of water reuse and its successful implementation has really been summarized quite well in these key publications, especially over this last decade. So with this, thank you very much for the opportunity to speak. Looking forward to Professor Leslie's presentation and the discussions that will follow.
Well, thank you very much, Professor Daigger. Your presentation was very succinct, and I'm very pleased with your presentation, which is very focused, okay, on this, what we refer to as the policy technology interface concerns. Yeah. And you brought forward ideas that are very practical, I mean, in terms of like policy design and implementation, okay? So thank you very much. And then you also finished your presentation within the 20-minute time limit, okay? Right on target, okay? Thank you very much, okay? So may I invite Professor Leslie, our second speaker, and the title of his presentation is Australia's Journey towards Integrated Urban Water Management, Past Achievements and Future Prospects for Water Reuse. Okay, so Professor Leslie, please. Professor Leslie, you have to unmute yourself.
Can everyone see my screen?
Yeah, I can see you. You have to share screen. We can see your PowerPoint slide now, and you have to go to presentation mode.
This one?
Presentation mode.
Presentation mode, sorry.
Yeah. It's right here.
Is it?
Yeah, yes.
Excellent. Okay, well, apologies for the technical problems. Thank you very much, Professor Li. It's a privilege to speak with you today and the guests who have joined the seminar at the Centre for Water Technology and Policy at the University of Hong Kong. And also I'm grateful to Professor Daigger, Mr. Fung, Mr. Yip, and Professor Li for also participating. I'd like to share with you some thoughts tonight on what's happened in Australia with the use of water recycling in integrated urban water management, what's been achieved, the barriers that have been overcome to date, and what remains, the future barriers that we need to resolve. So my presentation will really focus on two perspectives that have a policy element to it, associated with the use of water recycling to augment and secure supplies for urban Australia. The first perspective that I'll begin with is the achievements. It's the evolution of the various solutions to the technical and institutional barriers. And those institutional barriers involve the coordination between the various departments that are responsible for maintaining our water and wastewater systems in our cities, and also communicating with the public and planning. The second perspective will really talk to the challenges that Australia face, Australian cities experience. Some of them are similar to Hong Kong, so we'll try and focus on those as well, and how you do planning in a climate of uncertainty. So the 5 key points for tonight will be the various milestones in the growth of water recycling in Australia, the typical concerns around water reuse, the water quality risks, the financial risks, and the acceptance. Professor Daigger has gone through the treatment approach and the different levels of treatment that are required to remove different water quality parameters that are important. We need to look at this with the context of climate change, particularly changes in the frequency and intensity of rainfall events. You cannot look at water recycling in isolation. As Professor Daigger said, there are other supply options. I will focus on both desalination and stormwater harvesting because they're very important for coastal urban cities which dominate Australia. And then finally, we'll look at how to create flexibility to avoid policy conflicts between different departments that are responsible for managing everything in our urban environment. So we'll begin with just a few very quick facts about Australia. 90% of us live within 80 kilometres of the coast, and we're mostly located in 6 big urban centres. Even though it's a very big country, we're concentrated in urban areas. So there's a lot of similarities with Hong Kong. The density is not quite the same, but it's comparable. These cities are mostly supplied by surface water supplies from inland catchments. So again, there's similarities with Hong Kong and dependencies on the mainland for the large transfer of water. In a climate of uncertainty, when you have a 10% decline in rainfall, you generally see about a 30% reduction in runoff. And so what we've seen in Australia is that map there shows the decline in millimetres per decade in our average rainfall. And you can see on the East Coast where most of the people are, it's brown, meaning that it's going negative. So we're losing rainfall, and that's also occurring on the West Coast in Perth, where the blue line represents the annual rainfall since 1975 to 2006 and the annual runoff. And you can see that it's much lower than the historical average from 1945 to 1974. So there's a threat to our surface water supplies, and we need to come up with solutions. So water reuse has played and continues to play a big part in that. And the green part of this graph basically shows the growth since the early 1990s that's projected to go through to 2030 on how much of water recycling will contribute to the average demand for water in our capital cities. Some of that will be in the reuse of water for non-potable, so for irrigation, to an extent for industry, and some of it is on the potable, where it goes back into the raw water supplies to be then delivered. So there has been growth, and we're projecting it to go up to about 30%. But what were the 4 key technical and institutional reforms or solutions over that journey? The first was decisions that were made at the federal level by the Council of Australian Governments. That's where all the state governments get together, and they began the journey of reforming how we manage water in Australia, both on inland in our rivers, but also in our cities. The second reform, and that began in the early 1990s, and it continues to this day, but out of that have come some of the things that are really helping to drive water reuse. The second aspect is the development of guidelines that gave wastewater departments that were mostly responsible for recycling the water targets that were agreed to by the health and water departments on what were minimum standards. Now, this was done prior, or these were started to be developed prior to the national water reforms. So they were done on a state-by-state basis. And the first ones were in New South Wales that enabled some of our earlier dual pipe recycling schemes. Rouse Hill is one development, but the other one that people may remember was the development for the 2000 Olympics. That whole precinct was done with water recycling through a second pipe, so not for drinking. Towards the end of the 1990s, membrane technology became established as a very competitive option for treating water, both drinking water and wastewater. And the beauty of membranes was that the cost came down. The quality is very much independent of variations in the feed water, and the footprint was small. So it was ideal for dense urban areas, and that allowed water recycling to take off. By 2008, the work that was started by COAG and the Council of Australian Governments really came into fore, and that was where we moved away from having state-based guidelines to national guidelines. And the other significant thing that happened there was that the regulation moved away from sampling at the endpoint, so looking at water quality when the water left the plant, so coliform counts, virus counts, conductivity, turbidity. They moved away from those strict endpoint targets to looking at critical control points along the way. And that critical control point theory came out of the food industry, and it allows you to monitor a process continually while it's working, and it removes the onus from endpoint testing. And that's a tremendous way of convincing or helping to provide information to allow the public to make decisions about the safety of recycled water. It gets away from that argument of you have to wait till the tests for virus or bacteria come back. You don't need to do that. You can monitor things in the process, and if you get green lights at those stages, you know that the endpoint will be acceptable. So they were the 4 real big things that I think we've achieved. And you can see that it wasn't quick. It was over the better part of 18 or 20 years to get all those things in place. So what are some features of these systems? Well, the first one that I think is really important is water recycling builds on existing infrastructure. So unlike desal, where you need to build brand new intakes and plants and run power, most importantly, to greenfield sites, water recycling is leveraging the investment that previous generations have made in the collection of wastewater and the treatment of wastewater. And the small footprint associated with membrane plants allows space to be tacked onto the end of that to improve the quality of the water. And that's basically what we see there. The photo that I'm showing you is one of the big plants in Queensland at a place called Luggage Point. It's part of a large potable reuse scheme called the Western Corridor. There's an aerial view of the plant. and below there's an inside shot on one of the membranes. They're the microfilters. And so through the national guidelines, we can monitor the process all the way from the inlet to the outlet with 7 or 8 critical control points. If you get a green light at all of those control points, you know that the water meets those standards. And the standards are set up such that the residual risk to public health is less than 1 microdali. Now the DALI stands for the disability adjusted life year. And it is basically, it's a very, very high bar. To put it into some perspective, the DALI associated with a case of food poisoning would be around about 0.1 to 0.2. And so we all sometimes eat the wrong thing and we get a bit sick as a result of food poisoning. That's a DALI of 0.1. Water recycling for potable reuse is regulated to 1 in a million. DALI, so it's a very, very high bar. And of course, the public is aware now of this, the recycling process, moving the water from the wastewater catchment through the environment, back into the water supply, and then back out to the public via the existing water treatment plants. That's the indirect approach. So what's the second perspective? Well, the second perspective is the challenges. Why aren't we doing more of this? What's hindering it? So there are a couple of things that we first need to look at, and there's 5 of them. The first one is we really do need to spend more time about how water is used in the community. Essentially, improvements in efficiency, low flow shower heads, low flush toilets, low water demand washing machines, all are a more effective way, more cost-effective way of stretching the water supply than building new sources of water. So we need to look at water recycling, desalination, stormwater harvesting in the context of making sure that as our population increases, we can be more efficient with the use of water. The second thing is water is not, society doesn't exist around water. Water helps society to exist, but things go on. Economies change. So in Australia, a lot of our water recycling plants were originally built to supply oil refineries, but those refineries have closed. Other industrial uses have also shut down. So there's always the economy is always in flux, and the water industry needs to match that. So that leads to the risks of stranded assets. Certainly you can reduce the cost of potable reuse by piping it directly as desal is done, but there are still issues around the public acceptance with that, and Professor Daigger's spoken about that quite extensively. The fourth one is desalination. Australia exists around coastal cities. So desal is always there as an option. So how do you get the balance right between desal and reuse? But then also cities are catchments. Cities catch water, stormwater, and that needs to be factored in into matching our overall supply. So the photo at the bottom is a seawater desal plant, and you'll see that it uses the same technology as water recycling plants. Reverse osmosis membranes to do that last polishing step. And if you look at the power associated with that and convert that into a cost, you see that the orange line there is water recycling using reverse osmosis. The blue line is desalination using reverse osmosis. And as the price of power increases, the response in the cost of desalination is a lot steeper than the response of the cost for water recycling. So you can see as the cost of power goes up, water recycling doesn't move as much as desal. So we need to keep that in consideration. But governments like to act with certainty. So as those water supplies began to be threatened by climate change, the first response was to build desalination plants. And you can see here that during our biggest drought in the last 20 years, the millennium drought, so-called, desalination grew from 5 gigalitres per annum to over 500 gigalitres per annum. So it's now got a total capacity of 1.2 billion litres a day, consuming 260 megawatts. And all those big cities around Australia have built large desal plants. Now, how do we stop this continuing? Well, we can take lessons from Singapore. Singapore in 1996 had a water plan that involved building 6 desal plants to meet future demands. By 2005, the reality was they only had built 1 and they were planning for their second one. And the reason they were able to do that was because they put in 4 very large water recycling plants that are now morphing into a large single consolidated plant. So water recycling was making the maximum use of the water that they were taking out of the ocean and reducing the need to build more desal. But we also need to think about drainage. I mean, cities are catchments. Our cities are experiencing higher rainfall events with greater intensity. There's the period between rainfall events is getting longer, but when it does rain, we get a lot of rain. And I suspect that the same is true in Hong Kong. And so if we look at things like ovals, public spaces, a lot of those can be converted as this this is a facility at the university I work, where the local oval has been converted using a rapid recharge system that captures and allows the groundwater to drain very quickly, the rainwater to drain quickly. It's stored in those boxes that are covered in a geotextile fabric and backfilled with sand. You can see the guys installing it there. And then that water can be pumped out for non-potable use later on when it's not raining. These are all very good strategies that can be coordinated. And you can see that if we use kilograms of carbon dioxide emitted as a metric to compare desal with recycling versus stormwater capture, you can see stormwater capture is a low carbon option compared to potable recycling or desalination. So to pull all this together, how do we begin to manage our urban water supply in a state of uncertainty? And so a report was prepared for the national government called Water for Our Cities, Building Resilience in a Climate of Uncertainty, and it tried to make recommendations that sort of pull all this together. The first thing it recognised is that while there's been great alignment between the wastewater, the water and the public health with the national guidelines, there's still silos between other government departments, notably the government departments that are responsible for urban planning. They also have to manage traffic, they have to manage power, they have to manage schools, residential developments, commercial developments. So there's a lot of wheels to a lot of cogs to the machinery of planning. Water is obviously an important one, but the communication across that needs to be better coordinated. So based on that, each city really needs to work out what's the optimum portfolio, because demographics and industry changes, urban spaces change from city to city. To encourage that optimum water portfolio, there needs to be the appropriate incentives through pricing and property rights. Developers like to build developments that have green walls, that have amenities that allow people to enjoy themselves when they go outside. They like to see gardens. But if they can't get access to the water, be it stormwater or wastewater recycling, it doesn't incentivize them to develop those type of buildings. Professor Daigger spoke about the importance of community trust, and that needs to be across everything. One of the big criticisms of government in Australia is that someone would live in a street and one year the water company will go through and rip up the street to put in new water pipes. Then they put it back and everything goes back to normal. Then later on, the telecommunications company goes in, rips up the street, puts in optical fibre. Later on, the traffic department goes in and all, so that they get frustrated at that. Why can't these things be coordinated? That's all part of the trust package. There's been greater investment in research on urban water issues and also the development of demonstration projects that can show to the public how these systems work. And also there's been training for the people that work within the water and wastewater industry, in the public health industry, so that they're aware of the latest developments and can operate the plants. Also greater involvement of the private sector in providing the operators to run a lot of the equipment. But to drive all this innovation, the key recommendation was to reduce the fragmentation, particularly between the different regulatory and government authorities associated with urban planning. And finally, establishing a set of mandatory minimum water standards so that the water that is used in these urban centres is used to the maximum efficiency. It's a bit like the phasing out of incandescent light bulbs to be used to use either fluorescent or LED light bulbs. That simple act of optimizing energy efficiency goes a long way to reducing greenhouse gas emissions and also bringing down overall power demand. And the same thing applies in the water industry, finding uses for water that are the most efficient. And so here are some of the policy achievements to date that have tried to tap into those 6 recommendations. The Community and Trust, our Water Services Association of Australia, have produced a wonderful booklet that is called All Options on the Table. There was input from people in America and Europe, Singapore, parts of Asia, on strategies that have worked to encourage people to accept that there are alternative ways of developing water supplies. It doesn't have to be water coming out of rivers or falling from the sky. There has been strategic investments. They've been looking at the Western Corridor in Brisbane, the groundwater recharge project or the replenishment project in Western Australia, demonstrate that water recycling for potable reuse can be done safely. And to encourage development and stop fragmentation in New South Wales, in the city of Sydney, they're trying to develop an integrated planning. Rather than looking at a one-size-fits-all, they're developing 3 cities within a city and adapting water transport development to the conditions that exist in our, what are called the harbour city, the river city and the parkland city, which cover around about, will stretch for over 150 kilometres west to east, but try and treat each of those regions as different based on their topography and geography, and finding solutions that work there. So with that, again, I thank you for the opportunity to speak with you tonight and look forward to the discussion.
Well, thank you very much, Professor Leslie, for your presentation. Again, it's a very rich discussion in terms of experiences that you have encountered or summarized, okay, in the case of Australia. Yeah. Now, we have received several questions from the audience. But let me tell the audience, I mean, we're going to reserve questions, okay, for Professor Daigger and Professor Leslie until we come to the question and answer session, okay? So for audiences who have submitted questions, please be patient, wait until after we finished after our discussions, we have an opportunity to present their views on this matter. Yeah. Now, we are going to turn to our discussants, okay, for them to share with us, okay, their thoughts, okay. The webinar, let me remind the audience, okay, is designed to facilitate this exchange ideas between international speakers and our local discussants. Okay, the idea is not simply to bridge this policy and engineering divide, okay, it's also an opportunity for us here in Hong Kong to find out what's going on in other parts of the world, okay? And to look at the question to what extent and how we could learn from the experiences. Like in this case, the United States, Australia, if we're going to move forward, making use of what we use as a viable policy option. Now, in regard to the question, we are very fortunate, okay? We are very happy, in fact, yeah, that this webinar is co-organized, okay, by 2 key government departments who are concerned with water policy. And the first one is the Drainage Services Department, and then also the Water Supplies Department. So I'm very happy to introduce our first speaker, our first discussant, okay, Mr. Fung from the Drainage Service Department. And Mr. Fung is the Chief Engineer with the DSD, and he's going to share with us, okay, the views from the Drainage Service Department, okay, on this matter. What do we use? Okay, Mr. Fung, please.
Okay, thank you, Dr. Li. Thank you for inviting me to share some information with the audience in this webinar. First of all, I would like to spare some, give us brief introduction to the organization that I'm working with, just in case some of the audience are not familiar with the situation in Hong Kong. My department, Drainage Services Department, is responsible for the flood prevention and also the wastewater treatment in Hong Kong. On wastewater treatment side, we are responsible for the wastewater collection, treatment, and disposal. Over 90% of the population is served by our sewage network. Talking about water reuse or water reclamation, in this slide, I would like to show a plant that is on-paying sewage treatment works. The plant is one of the first water reclamation facilities in Hong Kong, and it started operation in 2005. This plant is located in a hilly mountain area. It is in the country park, and next to the plant there are a lot of religious sites and tourist ponds. So one of the consideration or driver for reclaiming the water from wastewater treatment is because its geographic location. It is in the mountain area and it's difficult. It requires very high standard for in the effluent discharge quality. So one of the beneficial use, because of the high quality of the effluent, beneficial use of this effluent is to reuse it. And we are currently use the reclaimed water for public toilet flushing. And the every day is about 300 cubic meter water is reclaimed. Apart from this plant, we have also other water reclamation facilities, but it is mainly for our cleansing and process use within our plants. All the water reclamation facilities in our department is currently of small scale. So, but the situation is changing. At the moment, we are doing some work to upgrade the Shek Wu Hui sewage treatment works. Shek Wu Hui sewage treatment works is, we need to do some upgrading work because of the developments, the planned developments in this area. It is located in the northern part of the new territory. Apart from the population increase, we need to, because of the discharge requirement, the location, because of its location, the discharge is to to the deep bay, which require very stringent discharge standard. Because of the flow increase and the load, we have to keep the load to the deep bay unchanged. So we need to upgrade the current treatment level from the secondary treatment to tertiary treatment. And also the footprint of the plant is maintained to be small, and we adopt some very compact process to do the tertiary treatment. And after the the membrane treatment, the water quality, the effluent quality will be quite good and quite very much ready for the next step for water reclamation. That is the background of the Sewage sewage treatment works. And you can see the name change. After the upgrading, we are going to adopt a new name for this plant. And that is to change to Sewage effluent polishing plant. And when the water reclamation plant is complete, the water will be used for toilet flushing by the public. There are some reason for water reuse in Hong Kong. I think water resource is quite limited in Hong Kong. That's what is one of the driver. The second is about the effluent disposal. If we can reduce the amount of water to be disposed, it can enable us to reduce the amount of water to be disposed through the water reuse. I think this is some consideration in our water reclamation project. I think I would like to stop here, and thank you for listening to me.
Okay, well, thank you very much, Mr. Fung, okay, for your sharing. Okay. Now I'd like to invite, okay, our next discussant, Mr. Yip. Mr. Yip is a chief engineer with the Water Supplies Department. And I know that Mr. Yip has been working closely. I mean, both departments have been working closely on this matter of water reuse. So may I invite Mr. Yip to share his views, okay,
Sure.
on this water reuse, this option of water reuse, okay, from the perspective of the Water Supplies Department, okay.
Thank you, Dr. Li. Good evening, everyone. It's my privilege to join this webinar to listen to the resourceful presentation of the expert in the water reuse. In the following, I would like to take a few minutes to share with you the situation in Hong Kong so that we can explore and discuss whether how Hong Kong can draw the on the overseas practice and experience in our local applications. This is the existing water supply in Hong Kong, which comes from three sources. One is the local yield. The second is the imported water from Dongjiang of mainland China. And the third one is the seawater for toilet flushing. Hong Kong itself is a city of water scarcity. Local yield just accounts for about 20 to 30% of our total freshwater consumption, which is far from sufficient to meet the local demand. Therefore, we have imported Dongjiang water from mainland China since 1960s to meet 70 to 80% of our demand nowadays. As presented by our expert speakers today, it's common over the world that recycled water is deployed for non-potable uses. But in Hong Kong, we have been used to supplying seawater for flushing since 1950s. It accounts for about 24% of our total water consumption last year, and therefore saving fresh water of 300 million cubic meters. This portfolio of water supply has secured 90% reliability in Hong Kong. That is, round-the-clock supply can be maintained even in a drought of a 1 in 100 return period. In order to better manage our water resources to meet the ever-growing water demand and support the sustainable development of Hong Kong, we launched the Total Water Management Strategy in 2008. We updated the strategy 2 years ago. We adopted a two-pronged approach with emphasis put on containing freshwater demand growth with a target of achieving 10% reduction of per capita consumption in 10 years' time. And the second, building resilient in our freshwater supply portfolio with diversified water resources, such as desalinate water to cater for the extreme climate change effect. Expanding the use of recycled water is one of our major initiatives to contain the freshwater demand growth. This does not only help saving the precious freshwater resources, which is important to the survival of the ecosystem, but it also reduces the effluent discharge in the ecosystem. Generally speaking, most of the recycled water in Hong Kong will come from the sewage, as it is our policy to take advantages of tertiary sewage treatment process for development of water reuse. If tertiary treatment process is adopted for meeting higher discharge standard as some water sensitive bodies, we will take the opportunity to consider paying the extra for further processing the treated effluent discharge to produce reclaimed water for non-potable use. That is to say, in Hong Kong situation, with the availability of other alternatives, it may be considered more favorable in terms of cost and energy consumption to carry out tertiary treatment plus reclamation solely for water reuse. I think this is there is sort of similarity to Australia's approach of building on existing infrastructure. Currently, we have a number of infrastructure projects in the pipeline to supply reclaimed water to different places, mainly in the new territories, starting from 2024 onwards. We will also devise long-term plan to replace saltwater for flushing in some places for cost effectiveness consideration due to the long haul of saltwater from the seafront. What I have mentioned about water we use in Hong Kong is 90% for toilet flushing. Other non-potable uses such as street cleansing, landscape irrigation only accounts for about 10%. So we should plan ahead to expand the usage such as district cooling, which has large consumption, or even portable use. However, for users other than flushing, we face some challenges. I noticed from our both experts' presentation that droughts and reduction in rainfall due to climate change should be part of the driving factors for water we use in the US and Australia. However, the current water supply in Hong Kong is reliable with the imported water from mainland China. People would not consider that there is importance or urgency to develop water we use. Besides, we looked at that from our opinion survey. Most people do not accept drinking recycled water for the time being. Even some medical practitioners have public health concerns such as Legionnaires' disease or using recycled water in cooling towers, not to mention drinking the water, recycled water. So in the implementation, what we have to do include conducting some research and studies to remove the misconceptions and uncertainties. On the other hand, we first start with flushing use and build up the public confidence for paving the way for other users. Certainly, we will strengthen publicity and public education. So today, platform is a good example for us to share successful experience from our expert speakers. I look forward to more public engagement activity to be organized later. If any one of you has other suggestions, you are welcome to share with me. Thank you very much.
Okay, well, thank you very much, Mr. Yip, for your sharing. Now I'd like to invite one of our colleagues with the center, Professor Xiao-yan Li, Professor Li is affiliated with the Department of Civil Engineering. He is also a co-director of the Center for Water Technology and Policy. Okay, and so Professor Li, please.
Thank you. Thank you, Fred. Yeah, again, we thank the speakers for the wonderful lectures. Taking this opportunity, I'd like to introduce some of our research work at the University of Hong Kong on water reuse. We talk about challenges and opportunities. We all know water is a valuable resource and Hong Kong is short of water supply. So water should be recycled and reused. So from this, the lectures of speakers, we know there's a wide range of possible wastewater or water reuse. But in Hong Kong, the option is limited. We don't have many options. Difficult to find users because we don't have a sizable or industrial water use and no agricultural water use. And other usages are quite limited. So based on a recent study by Water Authority, the possible water reuse is really for, okay, you look at this chart, majority of possibilities actually is toilet flushing. So that's likely the only possibility in recent years in Hong Kong for water reuse. That could account for 20 or up to 25% of total water consumption. Talking about toilet flushing, Hong Kong already has a unique toilet flushing system that is seawater for toilet flushing. So basically we have a dual water supply, double pipes, supply two types of water, the fresh water supply and the seawater supply. That the seawater supply here is to supply water for toilet flushing. That's seawater. So very great amount of water, seawater for toilet flushing, as the WSD colleagues just mentioned. And okay, what we are proposing or what we are examining is another option of water reuse. That is to use reclaimed water, treated reclaimed water to replace seawater for toilet flushing in Hong Kong. Why we're thinking of this? Because, well, seawater is free. Seawater, of course, is free, but the seawater usage can be expensive because the seawater is aggressive with a high corrosivity. So all those seawater systems suffer corrosion problems. So to minimize the corrosion problem, to reduce the cost in this regard, we are proposing reclaimed water usage for toilet flushing. So basically to replace seawater in Hong Kong. Again, we take advantage or utilize the existing dual piping or double pipe supply in Hong Kong. So we already have two pipes and we use the seawater for another pipe for toilet flushing. This is for non-potable use and with other use, not just toilet flushing. Seawater can only be used for toilet flushing, but cannot be for others like street cleaning, car washing, firefighting. But the treated water or reclaimed water can be used for those purposes. So we are aiming at 30% of urban water supply. Well, if this is an option, I mean, reclaim the water for toilet flushing, and you think through, you would realize this is really a risk and a demanding task because we are going to deliver the reclaimed water. Okay, used to be dirty water into millions of individual homes, households. So it's a massive amount of pipes into millions of homes. And there is a great concern of cross-contamination. So because there are risk problem involved with this degree of reuse or this type of reuse, because of cross-contamination or misuse of reclaimed water. So how to prevent this type of cross-contamination, there are methods like painting the pipes and very intensive inspection, but that cannot eliminate the possibilities. One of the methods proposed or suggested by WSD is to eliminate any possibilities to add colorant into the clean water to provide early or instant warning. So that is a very aggressive idea. So add color into reclaimed water. If there is misuse, cross-contamination and the connection, the problem can be identified instantly. Okay, to address that, for the selection of a suitable colorant, a long list of factors need to be considered or studied. For example, it must be safe, and the cost or dosage should be low, and the stability should be acceptable, and not going to cause staining problem for the toilets and the floor. And the impact to sewage treatment work should be minimal, which means after the treatment, the discharge is acceptable. Okay, in view of those factors or matters, we did a study on the selection of suitable colorant, and based on the basic requirement, it should be safe and should looks good. So the blue color should be a natural choice, and we have a shortlisted colorant like methylene blue and acid blue, those type of blue colors. And talking about the detection limit, the dosage should be low, and those two colors stand out, like a methylene blue and acid blue has a detection limit of 0.05 ppm. That's very low dosage. It's quite encouraging. And the staining problems, well, did a long-term test on toilet flushing and on spill on the ceramic floors. And the result shows acid blue is better or much better than methylene blue. Although the dosage is similar, appearance is similar, but the acid blue would cause less staining problems. And for the treatment, basically for the removal of the color before discharge, because those color would add in wastewater and give the color to the wastewater. So the treatment is carried out by the MBR process, membrane bioreactor. So after treatment, the removal is not that great. It's less than 40%, about 1/3 is 33% are removal. And that's not very high, but considering, okay, we did a study on the whole wastewater system, because not all those colored reclaimed water will be used in the water supply. It's only used for toilet flushing, that counts for 20%. So considering adding dilution factor plus the wastewater treatment effect, so the final discharge is about 0.05 ppm, just at the threshold of detection. This can be acceptable because we are talking about the blue color and discharge into marine water, which is kind of appear to be blue. So this type of discharge can be acceptable. So that's a quite a specific study on water or potential wastewater reuse in Hong Kong for toilet flushing and other purposes. At same time, okay, of course we need to consider this incentive for water reuse and reduce risk of contamination. But at the same time, we also need to reconsider the matters or questions like how safe is safe, or if it's possible to achieve risk-free for water reclamation and water reuse. With that, I thank the supporting to this research, and thank the Water Center for this opportunity. Thank you.
Okay, well, thank you very much, XY, for sharing your research work with us. I mean, on this topic, what do we use? Yeah. Now, I'm looking at a set of questions submitted by the audience. Okay, let me go through the questions, and then I'm going to Professor Daigger and Professor Leslie. I'm going to ask you, both of you. Okay, first question. Maybe I can start with Professor Daigger. Okay, yeah. So let me read out the question for you. Yeah, there are quite a number of questions. I'm going to select questions that are most pertinent, okay, to your presentation. Yeah. Now, Professor Daigger, in your presentation, you mentioned that it's very important to equip the public with knowledge of water supply issues and options to help kickstart the policy debate on water reuse. Now, could you please elaborate on the specific areas of knowledge that you consider necessary and sufficient for the public to gain some kind of a certain degree of water literacy, to appreciate the importance of including portable reuse in the urban water supply portfolio? Yeah.
So thank you. So the first thing is for people to understand their water supply and wastewater management, the system which they have. Where does their water come from? How is it processed? How is it ultimately returned back into the environment? And what quality is returned back to the environment compared to the original quality? So in helping people to understand that, they first come to understand first of all, by understanding where their water comes from, they will help to understand that that their water is not necessarily absolutely pristine in nature. So there is the treatment of the water that they're provided. Treatment is an important step. They also start to understand that the treatment is designed based on the quality of the water supply. They will also come to understand, quite frankly, that the water that they're receiving is not risk-free, because it cannot be. So Professor Li asked the question, can we have a risk-free water reuse? The truth is that our conventional water supply is not risk-free. It's a very small risk, as Professor Leslie has mentioned, in terms of reuse practice. In fact, by all technical analyses, the level of risk mitigation for water reuse is actually greater than what is typically applied in terms of conventional water supply. So, and that's appropriate given the nature of the raw material. One of the things we haven't talked about, though, also is that water reuse oftentimes becomes more of an option in people's minds when one considers the level of wastewater treatment that's truly needed to protect the environment to the level that people want it protected. And Mr. Fung, I think, can speak to that a little bit. In fact, he mentioned that as the population increases, we in fact have to, in terms of providing wastewater treatment, we need to do that in a fashion where there is no more discharge of material into the environment, because we're fully using the environment. There are many places where people are getting to the point where they realize that the treatment that is truly needed to protect the environment, the water that's being produced is becoming close to potable water anyway. So they say, well, why don't we just reuse it, since we are expending so many resources into treatment of the water that we've used. So, so it's understanding the existing water cycle, the existing urban water cycle, where the water comes, how it's treated before it's used, how it's treated after it's used. But in this discussion, I've highlighted how some of the important concepts that people need to evaluate water reuse as an option, certainly only as an option, but how some of those important concepts then can be conveyed relative to their existing system, to allow them to make a more balanced evaluation of reuse as one of the options among the variety that exist.
Professor Leslie, I have a question for you. Yeah. In the case of Australia, has the country come across any public health incidents that are linked directly to the use of recycled water? And if you have, then how?
So, yeah,
Yeah.
not with the planned indirect potable reuse projects. So there hasn't been any there haven't been any accidents that have led to any health concerns. However, there's a story about one of the first water recycling projects in Sydney. I think I mentioned it on the graph, the Rouse Hill scheme. That was a planned community that had two pipes, a purple pipe that supplied water to the toilets and the garden, and a conventional potable pipe that supplied treated drinking water into the kitchens, showers, the regular supply. In the development of that project, the pipes went in, the houses went in, people moved in, the water was supplied, the wastewater was collected, but the water recycling plant wasn't finished. So they commissioned the recycled water system with drinking water. So people were getting the one quality of water, but through two systems. And they got to know that. They were told that it would have recycled water, but then they looked at it, they found that it was no different. So for a few years, people were using both systems as though they were both potable supplies, which they were. When they finally switched on the reuse system, they then began receiving disinfected tertiary effluent. So it wasn't the high potable standards, but it was fully disinfected to prevent any acute illness associated with ingesting the virus, bacteria, or protozoa. The water department discovered that some people were still continuing to drink that water, even though it was being supplied with recycled water that was a lower standard. However, there were no incidences of any illness because people were still thinking that they were getting they were on the old system and were getting the potable water. So generally, the experience on disinfection of wastewater has been that, as Professor Daigger pointed out, it is so robust that it quite often exceeds the level of disinfection, both in chlorine contact time and dose, or UV dose, or in the case of Rouse Hill, it was microfiltration and some ozone, than a traditional water supply would get. So there was no public health outbreak.
Okay, well, thank you very much, Professor Leslie. Yeah, Professor
Don't tell
Daigger.
anyone that.
Oh, okay. Let me get back to Professor Daigger. One more question for you. Yeah. Now, you have already referred to a set of obstacles in the implementation of the option of water reuse, okay, in the United States. So I have this question from the audience, okay? And now, basically, it's a very straightforward question, okay? Now, between the technical and policy-related obstacles, okay, based on your experience, okay, what are the most common obstacles in the implementation of water reuse projects in the United States?
So the most most common deal with the policy and implementation, not the technology. It's because we've been focusing on technology for decades. The technology is quite mature, and Professor Leslie has done a very nice job of helping to describe some of the critical technologies that have allowed us now to provide this high level of reliability and assurance in terms of treatment. Where projects have failed to be implemented, it has generally been that the implementing entity has tried to go too fast and has not recognized the importance of bringing all of the relevant parties into the discussion. So a good example is, the Hong Kong discussants, discussers have mentioned, several of them have mentioned health concerns and so forth, both in the US, but Professor Leslie described this very well in Australia about the need to bring the public health professionals into a balanced discussion with sufficient time for a robust discussion to occur based on the facts, and to define the requirements to actually produce an acceptable quality water. And it must be benchmarked compared to the existing water supply. So that discussion exposes the water supplier to looking at their existing operation. One of the outcomes in many instances has been an improvement both in the conventional water supply as a result of that examination. But it's taking the time, bringing the parties, and legitimately and from a fact-based perspective, addressing the concerns, whether they're viewed as legitimate or not, but addressing the concerns on a fact basis, and reaching conclusions on that basis.
Okay, well, thank you. I have a question here which is addressed to both Professor Daigger and Professor Leslie. And the question is Legionella a concern for non-potable reuse cases in the United States and Australia? Legionella, yeah. So maybe Professor Leslie?
Please,
Yeah,
Greg.
so we the short answer is yes, but it's also a focus of work in potable treatment. So there's a project that we're involved with the Water Corporation of Western Australia that has a particular problem with some of their systems that rely on groundwater, where there is iron and manganese, and the system that they use to remove the iron and manganese from the groundwater, because the water is very good quality with all respects, other respects, has low turbidity, obviously. They run it through aerators, and the operators are exposed to droplets and sprays from those aerators. And like with any biofilm, there's the potential for Legionella bacteria to colonize the surface of the de-aerators, the aeration system, and slough off. So we do a lot of work trying to predict all the factors that lead to positive counts on Legionella. Quite often it's not so much the source quality of the water, it's more about how the aeration towers are maintained. In Victoria, we were involved in a project in the city where the recycled water was being used at a chemical plant, And inside the chemical plant, it was being used for general washdown water, chemical makeup water, so batching of chemicals that are used in the manufacturing process, and also in cooling towers. And again, a lot of work went on into looking at the inhalation of droplets and whether that recycled water would come into contact with surfaces. So the same risk management systems apply. The fact that we're using recycled water doesn't really exacerbate the risk over regular drinking water. If the surfaces aren't kept clean, if you don't have the droplet suppressors and things like that, the probability of inhalation of droplet goes up, and along with that, the probability of infection goes up if Legionella bacteria get established. Professor, is that your experience, Glenn?
Well, and in fact, in the US, if you take the Professor Li, the question, if the word reuse was taken out, so it's a concern about Legionella in the water system. So not only including where reuse is occurring, but in the entire water system, there is a growing concern about Legionella. There's a recent U.S. National Academy study looking at Legionella in the drinking water supply, and certainly cooling towers are an issue because Legionella, for those that are not aware, it's not a matter of the ingestion, the drinking of water with Legionella, but it's breathing and taking in water droplets that have Legionella in it because it's a respiratory disease. There's growing evidence that Legionella is an increasing public health issue with regard to the water supply, and the pathway is Legionella in the potable water supply, including in homes, so and in buildings and so forth, in terms of what's called premise plumbing, so within the homes and the buildings itself, and things like showers, the formation of droplets in showers or even in sinks and so forth. So Legionella is being widely recognized in the U.S. as an issue, but not particularly to water reuse, but to the water system as well. It's a matter of maintaining sufficient temperature because many of it's inhabiting the hot water supply, but maintaining sufficient temperature. And as people return to workplaces and so forth from the pandemic, this is a particular concern because we've had many places where the water has been quite stagnant to allow the Legionella to develop. Legionella actually resides in biofilms, but also in amoeba that are inhabit the biofilms, which are just naturally present in any water supply piping. So the fact that the systems have not been used, have not been flushed, the concern is that a population of Legionella has developed there. So the need for good flushing and so forth, as buildings in particular become re-inhabited compared to the use during the pandemic. This is something that certainly Hong Kong should be concerned about, as this is a concern on a global basis.
Okay, thank you very much, both Professor Leslie and Professor Daigger. I have one question for Professor Leslie. In your presentation, you mentioned the case of Singapore. Yeah, So that's a question, okay? The Singapore has adopted treated wastewater as one source of drinking water. To the extent that you know about what's going on in Singapore, do you think, generally speaking, Singaporeans are accepting treated wastewater as a source of drinking water?
So it's been a number of years since I've worked in Singapore. The main time that I was up there was during the development of the second part of the New Water program. The first part was in the 1990s, that finished in a demonstration project, and Professor Daigger was involved in that through the CH2M Hill work. The first 3 plants that went in had a fairly heavy public education and engagement campaign associated with it. One of the facilities in particular at Bedok had a purpose-built visitors centre with a theatre. The whole system was set up to be very, very transparent. Lots of the use of glass so that visitors would come and would see the various steps in the process, the screening, the disinfection, the membrane filtration, the reverse osmosis, the ultraviolet disinfection. Lots of additional educational facilities around where water comes from, how it's used. And then in concert with that, in the 2002 National Day on August 8, some recycled water, some new water as it was referred to, produced at those plants was delivered to the National Day ceremonies, and all of the government ministers consumed it. So it was sort of a statement of this water is good enough for us to drink. So I think there was a lot of support there. And then in addition to that, a narrative was developed all through the recycled water program that the development of water supplies that were independent of Malaysia, which was where the main catchment is for Singapore, was part of a national security narrative, the 4 national taps as it was called, of which desal water was one. Their local catchments that were quite small was the second, recycled water was the third, and water that was imported from Malaysia was a fourth. The concept being that at any one time, one or more of them could disappear and you'd still have other supplies to fall back on. So I think the combination of that public engagement from schools all the way through, making the facilities open to people to come and visit, that was part of the design. The national leadership and this sort of national security narrative probably pushed away our innate concerns about the yuck factor that I think we all feel whenever we have to try something new that doesn't quite align with whatever our original sensitivities on those issues were. So not surveying the Singaporeans personally, I can't speak to that, but I suspect that whole that whole approach has given them confidence in the water.
Okay. Professor Leslie, let me follow up with a related question, and that has to do with Australia. Yeah, there's a question from the audience, and that question is, what was the most crucial factor in the 1990s that triggered the government of Australia to adopt water reuse as a strategy to secure water security?
So yeah, I read that question. That's a really good question. I think historically, if people look at what happened, it was really the health of the inland rivers, particularly the Murray-Darling Basin, and how the state that the rivers had got into because of over allocation, not managing agricultural use, algal blooms, communities running out of water in the very dry years, that the federal government said that we need to do something about how water is managed. Their principal objective was to resolve the issues with inland water, and that led to the national water reforms. But because they were dealing with the state governments, state governments are responsible for water in the cities. And they said, we also need some national reforms on our urban water. And they agreed because, the cities can't grow without a water supply. So that it was started by the health of the rivers, but while they were doing that, Council of Australian Governments, they began to look at the water in the cities. And one of the biggest obstacles there was that there were no national standards. People couldn't talk to any, like we talked about the Singapore example where you had the government drinking recycled water. There was no mechanism to allow that to occur, even to have a standard approach for water quality. So, and that also applied to the drinking water guidelines as well. They were fragmented. So there was this whole, the rivers kicked it off, but then it went into looking at the regulations. The first one that they adopted was the Australian National Drinking Water Guidelines. And then shortly after that, they rolled out the recycled water guidelines. But the original one was the state of the rivers that got the federal government talking to the states and getting the states to cooperate on these national standards.
Okay, thank you very much, Professor Leslie. I have a question that would, I would say, concern our discussants. Okay, I mean, Mr. Fung, Mr. Yip, and Professor Li. Okay, let me read out the question. Okay, I have to rephrase the question. Okay, the question is a matter of to an extent. Okay, now Hong Kong has overly relied on imported water from the East River, and this over-reliance on imported water might have contributed to the underdevelopment of water reuse and adoption here in Hong Kong as compared to countries like Singapore. Yeah. So what do you think? Is that the reason? Is that one of the reasons why water reuse has been underdeveloped as an option in Hong Kong? Because we have overly relied on imported water.
What I have discussed is that point out that the current portfolio of Hong Kong's water supply in Hong Kong is quite secure because we have imported water from mainland China. But if you have noticed that on the other hand, we have also deployed the seawater for toilet flushing. About more than 20% of seawater has been deployed in Hong Kong. So we have already used different sources to deal with our water demand. So in Hong Kong, because as I said, the people in Hong Kong is not so acceptable to recycle water, even for non-potable use. So on one hand, we have already deployed the seawater for non-potable use, and on the other hand, actually, most of the imported water from China is deployed for potable use mainly. Although in some other cases, for example, where the location is far from the seafront, we have to use the fresh water. And for another other uses, for example, what I've said for the cooling tower, right now we still use fresh water because there's still other health concern. So actually, we have already tried to use the imported water for potable use, and we have already deployed other water source for non-potable use. So I think there's so complicated situation in Hong Kong. So we are trying to develop recycle water as far as practicable, and to the acceptance and to the satisfaction of the public. Yeah. This is what I can say. Yeah.
Oh, okay, thank you, Gary. Yeah. XY, do you have anything to add to this particular sort of like argument?
Yeah, it's good argument, but basically it's the case. It's also the good answer. I think there's water imported from East River. East River really changed the Hong Kong water supply. So basically reduce the need for water reuse. That's a fact in the past. At the same times, so basically that's already the answer. It's a good argument, a good answer already. But there could be the situation for the past. If we look forward for the next 20, 50, or 100 years, situation may change. Well, it's just in my opinion. So number one, the water from East River is becoming more and more expensive. It's not just water becoming expensive. Everything becomes expensive, and the water is not an exception. So water price is getting higher and higher. If that is acceptable, you also look at this demand on East River water. So Hong Kong used to be the #1 user, the dominant user, but now you see this the cities, what's that? There's Dongguan and Shenzhen. Shenzhen even built their own water supply line from East River to provide water to Shenzhen. So people need more water from East River. So now I think this supply is reliable, sufficient, but with continuous growth and industrialization, different usage, and the reliability of water supply from the East River need to be evaluated. At the same time, Hong Kong need to looking for other alternatives. So again, as for that question, that argument, that's the case in the past, but it may not be the case for the next 100 years, and we need to, again, look forward, plan ahead. Yeah, Fred, yeah.
Okay, thank you, XY, yeah.
Sorry, Dr. may I have some supplement?
Sure, please.
Yeah. And also I would like to supplement from the engineering point of view, because in Hong Kong, when we are carrying out infrastructure project, our main concern, the prime concern consideration should be the cost effectiveness and environmental implication. For the Hong Kong situation, the most cost-effective solution mostly is the seawater, because we are just is a coastal city, and the other one is actually the process in recycling water. It is still also have some environmental implication, because it consumes energy. So we have to take into account all these factors in choosing the right solution to solve our problem. Yeah.
Yes, please.
Yeah, I want to supplement some information. In the past, the urban development of Hong Kong usually along the coastline of the city, but now that we are moving inland. Take the example of Sewage, that is quite far away from the sea. So the disposal, the effluent disposal is an issue. So if we look into the future, I expect there will be more and more water reuse opportunity, and in fact that is a very prime driver for water reuse in Hong Kong.
Okay, thank you very much, Mr. Fung, and thank you, Mr. Yip, for your thoughts, okay, for your views in regard to this question about the prospect of water reuse. Yeah.
Professor Li, could I make a comment?
Yes, please.
you know,
Yes.
there's a tendency when we talk about water reuse to focus on the water supply aspect. But, you know, Mr. Fung has touched on this. Really the three discussers have touched on this, but the other aspect is the wastewater discharge. So as communities grow, the volume of wastewater increases as well, which requires a higher and higher level of treatment to, you know, to meet the environmental objectives that we have set and so forth. So one of the other drivers for reuse is at a point where one reaches the point that the level of treatment that's needed, not just removal of organics, but first the removal of nutrients, but then beginning to be concerned about the introduction of recalcitrant organics into the environment. When one reaches that point and you really look at the level of treatment that's needed, you're very close to producing potable water anyway, or at least very close to a water that can be used for many reasons. And that is one of the other drivers in many locations, but certainly in the, you know, certainly in the U.S., there's a notable project, significant indirect potable reuse project being implemented in Southeast Virginia at this time. I'm actually the chair of the independent review committee for this, but it would remove it will provide augment the groundwater supply. But one of the principal reasons that the project is going forward is it will take nutrients and other constituents out of the Chesapeake Bay. The Chesapeake Bay being a national resource, which is the levels of treatment that are being required and needed to achieve the environmental goals are approaching very, very low levels. So Mr. Fung was mentioning this. As you move away from the coasts into the into the new territories, you know, you're producing. You're not only needing more water, but you're producing more wastewater, and the opportunities to manage that are becoming more and more restricted in terms of, and more stringent treatment is needed. So I want to come back to this idea of looking at water as a whole. Look at water as a whole and put water reuse on the table, not only dealing with water supply, but also effluent management, and then make good decisions. So it's very important, I think, to look at the whole picture, including not only the water supply, but also the effluent management in making these decisions. Reuse can address both sides. Things like desalinization only addresses one side of it. So that just has to be weighed.
Okay, thank you, Professor Daigger. Yeah, I have a question here in regard to, for lack of a better way to say it, okay, basically the concern, okay, about the potential impact of pharmaceutical contamination in the wastewater for reuse. My guess is that I think recently in the news, okay, you can actually test the wastewater, okay, for a drug use pattern, right, in communities. I think in the case of Australia, that was the case, yeah. Meaning, well, you can actually test wastewater and see whether or not in the community people are using certain drugs, okay, yeah. So this question about the potential impact of pharmaceutical contamination, okay, in what we use, is that a concern? Should that be a concern? Or as you, Professor Daigger, as you said, okay, technology has already matured, okay, in regard to wastewater reuse, so much so that there may not be a concern. Yeah. Well,
I'm suggesting that water reuse is a solution, because the most advanced technology that we use for wastewater treatment removes some, but not all of those constituents. So it's very effective in terms of removing some, but not all of those constituents. So, so even our most advanced approach to wastewater treatment is allowing some of those materials to enter into the environment. When we reuse water, we apply additional technology to control those constituents. So depending on the use. So the water reuse can be a solution to the fact that those constituents are in the wastewater stream. They come from us. They come from us because we're using those materials, and our body, our body uses as much as is needed, but the therapeutic dose is greater than the amount that the body needs, and we excrete the remainder. But the technology is there to remove it. The technology is well demonstrated and there to reuse it, there to remove it. But applying the water to higher uses then provides the justification and the cost offset to then apply that technology and control those discharges.
Okay, I think maybe Mr. Fung can talk about this terrestrial treatment and whether or not to extent that could address this kind of concern. Yeah.
I think I think the traditional activated sludge process has already removed a lot of those materials, but they cannot remove all. When we are concerning about the POPs, the pharmaceutical byproducts, then I think that those processes if we are concerned about this material, we are looking at other technology that can help. I think membrane or some membrane technology may be considered in the future.
Okay, thank you. Yeah, Mr. Fung. Yeah. I think we have time for just one more question. Yeah, let me see.
Well, I want to
yes,
add
please.
one more point. Microplastic is also a concern in some people's opinion, and I think the membrane technology is good to handle microplastic. When you adopt this technology, membrane technology, that means the effluent quality is already very high, very close to at least to non-potable reuse. Based on this consideration, I think I can see there will be more and more opportunity to reuse the water in future.
Okay, well, thank you very much, Mr. Fung, for your observation. Yeah. Yes, we are close to 8 o'clock, so only a minute away. Yeah. So let me take this opportunity to thank all the audience, yeah, who have logged on to this webinar. And also let me thank Professor Daigger and Professor Leslie to be our speakers, okay, for tonight. And I'd like to thank Mr. Fung, Mr. Yip, and my colleague, Professor Li, Professor X.Y. Li. Yeah. And I'd like to thank my colleagues here, okay, operating the webinar platform system in this conference room, okay. So it's been a very interesting 2 hours discussion on this topic, wastewater reuse. Excuse me, I just say wastewater, right? Water reuse, yeah. Well, it's Freudian sleep, yeah. Water reuse, okay, and increasingly, this is an option, as Mr. Fung and Mr. Yip has already pointed out, okay, an option that's increasingly getting attention here in Hong Kong, yeah. And I hope this webinar will serve as a platform for us to sort of start thinking about, okay, the pros and cons and set up a sort of like the some kind of like knowledge base, okay, for us to look further into this option, okay, for Hong Kong, okay, as Hong Kong develop or refine our long-term water strategy, okay. So thank you again, Professor Daigger, Professor Leslie, okay, for joining us tonight. I'll bring the webinar, okay, to an end, to a conclusion by now. Okay, thank you. Yeah.